Good morning. I want to do some reviewing about how to factor quadratic trinomials this morning. A quadratic trinomial. Sometimes we think of these as meaning the same thing, but they really don't. A quadratic is a second-degree problem, meaning it has an x squared as its biggest exponent. A trinomial means it has three terms. So it can be a quadratic without having three terms, and it can definitely have three terms without being a quadratic. A quadratic trinomial is going to be anything of the form something x squared plus something x plus something else. We're going to talk now about the problems where a is just a 1. So these problems are all going to be just of the form x squared plus or minus something else plus or minus some other number. And we're going to be talking about problems that have both the middle term and the last term. Let's look at what happens if we multiply two binomials. Let's say we want to multiply x plus 3 times x plus 5. So we FOIL this out. The first will be x times x is x squared. The outer, the O, x times 5 is 5x. The inner terms, 3 times x is 3x. The last, 5 times 3 is 15. And typically the middle terms will be like terms, and we can add those up. In this case, that gives us 8x. So what we're looking for is how to go in reverse from this. The 15 comes from multiplying the 3 and the 5 together. A positive 3 times a positive 5 is a positive 15. The 8 comes from adding the positive 5 and the positive 3, because those will automatically become coefficients of the middle terms. So the 15 is 3 times 5, and the 8 is 3 plus 5. So let's look at an example. What if we look at x squared plus 5x plus 6? As long as it's just a plain x squared, and if you've got a number in front of the x squared, this turns into a whole different ball games. But in this case, as long as it's just a plain x squared, then these are going to be an x times an x. We didn't even bother here to talk about how the x squared came about, because it was just x times x. The numbers that go here have to multiply out to 6 and add up to 5. Now, because there are a lot more ways to get two numbers to add up to 5 than there are to get them to multiply out to 6, we always start from the back. So we're going to start from here. And we're going to look at what numbers can be multiplied out to get 6. Factors of 6 are 1 times 6 and 2 times 3. Those are the only integer factors we've got. So work our way backwards. Now we look at the plus. When you multiply two numbers that have the same sign, you'll get a positive. So we know these are going to have the same sign. And when you add two numbers that have the same sign, you add the number parts and keep the sign, right? Like -4 added to -5, because these have the same sign. We add the 4 and the 5, and the sign that we had was a negative for both of them, so it's going to be the -9. So if two numbers have the same sign, you add the number parts, the absolute values, and then you keep the sign. So since we know this is a +6, they have to have the same sign, which means we're going to add these and keep the sign. Now these two add up to 7. These two add up to 5. Since we're looking for a 5, it's going to be the 2 and the 5, 2 and the 3. Now, figure out what you need to have as far as the signs in front of the 2 and the 3 to get a +5 out of it. And of course, to get a +2 and a +3 will add up to a +5. No other combination of signs will work. So this is the factorization of x squared plus 5x plus 6. And if we FOIL this out, notice that we get x squared, a +3x, a +2x, and a +6. And this will be the x squared plus 5x plus 6. What if this had been x squared minus 5x plus 6? The factors of 6 are still 1 and 6 or 2 and 3. So we factor this, and then this tells us whether we're going to add or subtract these two numbers. This says add, so again, we can come up with a 7 and we can come up with a 5. And by the way, these are the only two numbers that could go here and this factor. So if this was a 2, it wouldn't factor. If this was an 8, it wouldn't factor. Anything but a 7 or a 5. So I can go ahead and put the parentheses. I can go ahead and put the x's. And since I want factors of 6 that add up to 5, it still has to be the 2 and the 3. The difference this time is that I want the 2 and the 3 to add up to a negative. I got the 5, a -5. So in order to get a -5, it's going to have to be a -2 and a -3. So -2 and -3. And if you check, this will FOIL out to x squared minus 3x minus 2x would be a -5x, and a negative times a negative is going to be a +6. What if it had been x squared minus 5x minus 6? I like the 5-6 combo because it will actually factor no matter what kind of signs I put in there. Now here, I'm still looking for factors of 6, and it's still 1 and 6 or 2 and 3. But now this tells me I'm going to subtract these. When I subtract these, the difference between these is a 5, and the difference between these is a 1. So if this is a minus, the only numbers that can be in the middle are a 5 and a 1. If this is a plus, the only numbers in the middle term have to be a 5 and a 7. And this combination works with a 5 regardless of whether you're adding or subtracting. Those are actually the trickiest ones because you have to really pay attention, not just automatically assume something. That's where we usually get messed up. So now I want the factors of 6 that subtract to give me 5, and this time it's going to be the 1 and the 6 combination. To get this to come out to be a negative 5, it will have to be a negative 6 and a positive 1. Multiply it out. It's going to be x squared minus 6x plus x, that's a plus 1x. Positive 1 times a negative 6 is negative 6. And these are going to give me the negative 5x. And by the way, if this had been x squared plus 5x minus 6, we would still need factors of 6 that subtract to give us 5, which would be the 6 and the 1. But now it has to be a positive 5, so it would have to be a plus 6 and a minus 1. Let's look at a couple other combinations. What if we had x squared minus 7x plus 12? 12's factors would be 1 times 12, 2 times 6, 3 times 4. Already used the 4, so that's it. Factors of 12 that add up to 7. Well, this adds up to 13. This adds up to an 8. This adds up to a 7. Boom. So it's going to be an x and an x. And it's going to be a 3 and a 4. The factors of 12 that add up to 7. And then to get the negative 7 out of a 3 and a 4, it's got to be a negative 3 and a negative 4. What about x squared? What if this had been a minus 12? What could go here? That makes a good test question. What numbers could go here and have this factor? Factors of 12 are still 1 and 2, 1 and 12, 2 and 6, 3 and 4. Now the factors would have to be subtracted. So if I subtract, here I can get an 11. I can get a positive or a negative, depending on how I put the signs in. Here, the difference is a 4. Here, the difference is a 1. So the only numbers that could go here would be 11, 4, and 1. So what if it had been a 4? And these could all be either a plus or a minus, just depending on what signs I put here. So say this was a minus 4. How would it factor? X and X. To get a 4, I'd have to use a 2 and a 6. To get a negative 4, it'd have to be a negative 6 with a positive 2. There's your factorization. It takes some practice, of course, but that's all there is to it. So see you again next time. Take care.